Okay, let's look at another example here. Okay, so the same idea applies in the sense that now, since I'm looking at the limit as x approaches infinity, I want to know what's happening in my numerator. All right, as x approaches infinity, what does x to the fourth plus 4x approach? And so we know that the general shape of x to the fourth looks like a upwards U shape, right? And so as x approaches infinity, I know that x to the fourth plus 4 is also going to approach infinity. So here I get that this is infinity. And then the limit as x approaches infinity of x plus 3 is going to also be infinity, okay, because as x approaches infinity, I know that the line x plus 3 is also going to approach infinity. Okay, so again, I'm just talking about the end behavior of the numerator here and then of the denominator here. Okay, so then from here, what I need to do is I need to divide by the term with the highest degree in the denominator. And so here I want to divide by x because the highest degree in the denominator is 1. And so I'm going to divide by that term x. So divide top and bottom by x, because this is the term of the highest degree in the denominator. So let's do it. We have that this is the limit as x approaches infinity of x to the fourth plus 4 over x divided by x plus 3 all over x. And so we know that this is the limit as x approaches infinity of x to the fourth over x plus 4 over x divided by x over x plus 3 over x. Okay, so the same trick as what we were doing in the last video. I can break up this fraction in the numerator here, the x to the fourth plus 4 over x, into these two smaller fractions here. Okay. And so now I just want to simplify. So I'm going to say that this is the limit as x approaches infinity. X to the fourth over x gives me x cubed plus 4 over x. This is all over 1 plus 3 over x. Okay, so now let's just look at each piece. So let's look at x cubed, let's look at 4 over x, let's look at 3 over x, and let's look at 1 here. Okay, so we know that within the limit that 4 over x and 3 over x are going to go to 0 because I'm in that 4 over infinity and that 3 over infinity case. So here, I know that this is the 4 over infinity is going to go to 0. And then I also know the same thing as 3 over infinity. Okay, but what about x cubed? What's the limit as x approaches infinity of x cubed? Well, we did this actually in our class practice, and so thinking about the end behavior there, you would say that as x approaches infinity, my function x cubed also approaches infinity. And so here you should get that this is equal to infinity plus 0 over 1 plus 0. And so infinity divided by 1 is still just going to be infinity. All right, so if you have infinity divided by a positive number, that still is going to give you infinity. Just think about the fact that even though I'm multiplying infinity by a positive number, if I'm dividing it by a positive number, it's still just going to be a really huge number, or it's just going to be this huge just abstractness. It's still going to be infinity, all right? And so it's not really changing anything if I say, like, divided by 1 or something. It's still infinity. Okay, so now, looking at, is there a horizontal asymptote line for the graph of the function f of x is equal to x to the fourth plus 4 over x plus 3? Okay, let's think about this here. I got that this limit was of my function here is equal to infinity. All right, I did not get a number, and so that indicates to me that there is no horizontal asymptote line.